Yeah, we're live.
Yeah,
Shall we start?
yeah, sure.
Hi, everyone. I welcome you all to the first talk for the day by Women in Data Science Noida. Women in Data Science is a global initiative by Stanford University. It aims to inspire and educate data scientists worldwide, regardless of the gender. It was started as a one-day technical conference. Today, 5 years later, it has more than 150 plus regional events worldwide. It in 60 plus countries, reaching over 1 million participants. I am Shubhika Bhardwaj. I'll be your WIDS host for the day. I'm a software development intern at SAP Labs. Being a machine learning enthusiast, I have been to several conferences and hackathons. I have been a Google Travel Grant recipient for the TensorFlow Dev Summit. I have also been a finalist at Hack In Out and many other hackathons. I would start by introducing our speaker, Bhavna Singh. She is a marvelous speaker. She is a learner, an enthusiast, an opportunist who continuously challenges herself to explore the world of machine learning and data analysis. She's currently working as a machine learning engineer at AI Smarts. Over to you, Bhavna.
Hello, everyone. So, first of all, it's a Sunday morning, and some of us find it really difficult to get up early on weekends. So, I really wish that this session adds value to everyone who's attending it. But before starting, let's first appreciate the whole Women in Data Science team who has been putting in so much efforts to conduct these sessions. Thank you, guys. This would not have been possible without you.
Thank you so much, Bhavna, for such a warm welcome to the audience. I think we can start with your talk now.
Yeah. So now let's talk about what I have got for you in today's session. So I'll be talking about the challenges in the AI industry, things that AI can't get do for the business, and what are the opportunities that lie behind those challenges. So without wasting any more time, let's get started. So this is really a very interesting picture that I found on the internet, and it speaks volume about today's era where AI is deemed as a golden egg laying goose by businesses and governments. Every day we witness different kind of breakthrough researches and new achievements being unlocked by AI. It seems like we are riding a new wave of revolution, which is all set to automate the boring, mundane tasks, and even more than that. From reading about a driverless car to actually seeing one running on the road, AI has really come a long way. However, this is just one side of the story, and there are several limitations which often get overshadowed under the promises of the technology. So we need to identify these challenges and look into the ways through which we can contribute to the development of the technology. We all know that AI is rapidly growing and research is still ongoing in many fields. So it is very essential for us to identify these opportunities and find out how can we contribute to the development of the technology. Moreover, it is very essential for the business leaders to equip themselves with the knowledge about the limitations of this technology. So, the very first challenge that I want to talk about is the curse of data annotation or data labeling. A major chunk of machine learning is based on the fact that we train our computers using labeled data. In simpler terms, if I want my computer to look at an image and predict whether it's a dog or not, so I firstly need to show my computer what a dog actually looks like. This will require several images that are labeled as dogs and several other images that are not labeled as dogs. So the problem here is who annotates the data. Data annotation or labeling requires a large human force. And big tech companies like Google, Facebook, they hire massive amount of workforce who spend hours labeling the data. The irony here is that we are trying to make smarter systems, but they actually require substantial amount of human force. This is not smart. Let's take an example. Suppose you are trying to build an AI-based system that can detect the damage occurring in the lungs due to coronavirus. For that, you will need several chest X-ray images of lungs that have been properly labeled under the professional guidance. We can't even think of the consequences of using improperly labeled data in this case. So, what's the solution? What can be done? Should we continue hiring the workforce for this sort of task or automate it? So the first solution is reinforcement learning. As you can see in this picture, the concept of reinforcement learning works on the simple fundamentals of the reward system, which is used to train robots. The idea can be to use design labeling systems that work on the basis of a function which is rewarded every time it labels correctly and is given a negative reinforcement for every time when it predicts wrong. So a very interesting use case can be a reinforcement-based recommendation engine, which is rewarded every time a recommendation-driven sales occur. The second solution can be GANs, which is an abbreviated form of generative adversarial networks. It is a semi-supervised technique where two networks compete against each other. So as you can see in this picture, the picture has been borrowed from this person does not exist.com. And as the name says, this person really does not exist. So this is an automatic image which has been generated by AI, and the technique in the backend is called GANs. So it is a semi-supervised technique. And let's say if you are trying to build a GAN similar to this, you will need two networks. One network which can distinguish between the fake and the real images of humans, while other network confuses it by showing the images that looks like human but are not actually. So data labeling systems which work on this technique can significantly reduce human dependency by generating images that seem so real. The third solution can be unsupervised learning. This is a technique where we have got unlabeled data and we want our machines to learn something from it. Unsupervised learning is considered as a very hard problem because in the absence of the labels, the computers don't know what they are being trained for. Unlike supervised learning, where we have got labels and computers know what are they getting trained for. So I would like to highlight this amazing work by Mohammed Terry Jack, where he built an unsupervised learning-based system that takes an image as an input and assigns one of the line colors to any pixel given its coordinate. So the image on the left is the original image which was taken as input, and the image on the right is the image that is generated after performing the clustering. You can see that the second image looks quite similar to the first one. So this is how unsupervised learning works. All these techniques are still in the development phase to solve the challenge of data annotation. So if you're really interested, you can start on this early. So the second challenge that I want to talk about is the requirement of massive training data sets. The current AI-based applications not only require labeled data, but also massive data. Let's look into some popular data sets and their sizes. So the first one is COCO dataset, which is of Microsoft, and it has got 1,20,000 images. The second dataset is ImageNet, and it has got 1.5 million images. And third dataset is Places to Database, which has got almost 10 million images. But these are just handful examples from computer vision. There are several others. In fact, if you think of the biggest players in AI, which are Amazon, Google, Facebook, etc., they're leading because they have access to so much of data. So let me explain this with the previous example. Suppose you are trying to build an AI-based system that can detect COVID by looking at the chest X-ray images of lungs. Will the system designed on the US patients work on the Indian patients? The answer is clearly no. The spread of COVID varies according to the geographies, and hence several other factors have to be taken into account. Hence, to build such a system which can detect COVID irrespective of the geographies, you have to collect a very large data set. So, what are the possible solutions? What can be done to solve this problem? One solution can be simulated learning environment. So this is one technique that can be used to reduce the data size. It works on the principle of training the data in virtual environment. Such systems can be built that are pre-trained in virtual environments with different variants of a task. So for example, if you are trying to build a robotic arm like this, you can it can be trained in a simulated environment to pick up paper cups, and then it can learn in the real world how to pick up bottles. This will save time and efforts as the system has already learned something and it does not have to start from scratch. This technique is in the early phases and a lot of work has to be done. The second solution can be transfer learning, but I'll explain this later in the session. Moving on, we have got the problem of data quality. So there is a very old saying, garbage in is equals to garbage out. This statement resonates more with the field of AI. If your model is fed with bad data, then you can't expect quality results. For example, if you're building an autonomous car with a data set where pedestrians have been labeled as trees, what will happen? The car will overrun the pedestrians. This is not what we want. According to a survey, Uh, According to a survey published in Harvard Business Review, 80% of data scientists' time is spent in cleaning the data and bringing it into the state where it can deliver results. But even after applying so much effort, all defects of data can never be corrected. Data cleaning is a time-consuming process and it's unique to a problem. So for example, if you have got an access to, let's say, online transactions data, and you want to build two use cases out of it. So let's say churn prediction and customer segmentation. So both use cases require different data preparation. You can't work with one data and solve two problems. As the problem changes, the data preparation changes. And this requires a lot of time. So due to these manual efforts, this becomes very cumbersome, and we don't want all our energy to get concentrated in data cleaning. So, what are the possible solutions? What can be done to solve this problem? First thing can be done. That is the first thing which should be done is zero communication gap. The problem mainly occurs when the team, which is responsible for data collection, is not aware of the intention with which the data is being collected. Clear transparency should be maintained across the organization, and the team of AI professionals should clearly communicate the purpose of collecting the data and make the data collection team aware of the consequences that can occur if the model is fed with the bad data. So this is a very important concept, and a lot of time the data collection team is not aware and they just do whatever they feel like. So this should not happen, and we should maintain no, we should maintain a complete transparency, and there should be zero communication gap. So moving forward, the second solution is mandatory feasibility study. So before kicking off a project, some time should be allotted to the data professionals in which they can perform in-depth data quality analysis and check the feasibility. A proper report should be prepared with all the data errors and it should be given back to the clients. So this will not only create a room for improvement, but will also allow cleaner data generation. So as you can see in this picture, the first step should be define the business problem, where you identify the use case and you see where should like how should this help the organization and where should the data come from. This all comes under the defining business problem circle. Now, the second thing should be feasibility study, where you perform in-depth data analysis of the data and identify whether it's even possible to perform the use case or not. And then third step should be towards the prototyping or the productionizing the model. So this is how the cycle should go. There should be a mandatory feasibility check in between. The third solution can be quality assurance metrics. Various metrics can be decided on a prior basis And scoring should be done at every data manipulation step. This will ensure that data not only remains accurate but also consistent. So, moving forward to our next challenge, which is the problem of data bias. Works of Julia Angwin, works of Julia Angwin and many others who have written about machine learning algorithms have clearly stated that our data sets are biased because these works have really showed how machine learning algorithms are biased towards black people. This might be intentional or unintentional, but it is absolutely necessary to stand up and become responsible for what we do. Let me explain this with an example. Suppose you are trying to build a system which can be used to tell whether this person can be issued a loan or not. You chose a data set which was heavily skewed. It the most of the records were of the instances where the loan was issued to male, and there were very few instances where loan was issued to female. This does not mean that women are less capable of availing a loan than a man, but it's a clear unintentional mistake of data collection. What will be the impact of such a system getting implemented in the society? So, this is not what we want. We should be responsible, we should look into the data and try to identify the bias that might be present in the data. Often these biases get covered under the name of advanced analytics or proprietary algorithm, but this should not happen. With governments becoming more and more interested in the technology, the technocrats should become aware and responsible that these prejudices and biases don't get implemented. One more thing that I want to highlight here is about the public data sets. Many products and applications are based on the commonly available data sets as they're free to use. For example, we have Cypher, which is popularly used for object recognition. These datasets are shared in the AI community and are often used for benchmarking algorithms. Imagine if the bias is present in publicly available datasets, that it can quickly get replicated and scaled. So, is there any solution? The first thing is own the responsibility and become more responsible. If you are designing or building these systems, then think about the ways in which it can impact the society and try to identify the inherent bias that might be present in the data. Since we are building these models, therefore we are accountable for it. So I can't emphasize more on this fact that it's completely your responsibility. You can't let something wrong happen to the society because of you. The second solution is establishment of global communities. So a lot of work is already happening in this space, and many people are coming together to form groups that collectively work towards responsible AI. For example, the International Technology Law Association, ITech Law, with memberships of technology attorneys and law firms with more than 70 countries, has published Responsible AI, a global policy framework. The framework is based on 8 principles, which are ethical purpose and societal benefit, accountability and transparency, explainability and fairness, non discrimination, safety and reliability, open data and fair competition, privacy and AI, and intellectual property. But this is not enough. We need more people to come together and form such groups who work voluntarily for the establishment of responsible AI. So far, I have talked about the challenges that were somehow related to the data. Now, let's move on to the other challenges and talk about the explainability, the interpretability problem. Remember the times when you asked your mom, why can't I go out and play? And she replied, because I say so. This is exactly the problem with the black box AI. The problem is not new, and a lot of research is still ongoing in the field. This is structurally hard and is becoming harder as more and more complex models take over. An AI-based application can be very accurate and very fast, but if it can't tell you why the prediction results are so, then it is probably not going to perform well in the market. So let me take an example and explain it to you. Suppose I build a system that can predict breast cancer with 99% accuracy, and you go to a hospital for the adoption of the system. The very first question that would be probably asked from you will be, how can your model say that this person is suffering from the cancer? Like, this is actually happening in the market space. People are asking why AI is giving this result. And you should know why this model is saying this person is suffering from the cancer. So people need to know the factors and the manners in which these factors are contributing to the results. This calls for the need of explainable AI. In use cases such as landing a loan or criminal justice, it becomes utmost crucial to know why a given person can be lended loan, and why uh, and on what basis does a model classify this person as a criminal. So what are the possible solutions? What can be done? There are a few open source Python packages for different variety of algorithms that are really helpful and are trying to help in this space. Some of them are Google's WIT, which is abbreviated for What If tool. So it is a very handy tool, and it enables user to evaluate their ML models. Bit is very user friendly, and therefore it is very easy to use because of its GUI. The major attraction of this tool is that it allows you to visualize the inferences and gives you a freedom to change the data and see its impact. So this is really very helpful. You can go later, or you can, after the session ends, you can read about it more on the internet. The second package that I want to talk about is IBM's AI Explainability 360. AIX stands for AI Explainability. So this is an open source toolkit which allows you to comprehend the ML models. It contains 8 state-of-the-art algorithms that help you decode the prediction results. The third, and my favorite, which is LINE, and it stands for Local Interpretable Model Agnostic Explanations, is another popular framework which is used for answering the questions of why and solving the black box mystery. The output of LINE is a list of explanations reflecting the contribution of each feature to the prediction of a data sample. This provides local interpretability, and it allows you to determine cha- which feature changes will have the most impact on the data set or most impact on the prediction. So let me give you an example. Suppose we are trying to build a system that can predict by looking at an image whether it's a human face or not. Then these tools will help you identify these features which contribute most to the human face. These features can be eyes, nose, cheeks, etc. So this is all about the issue of explainable AI, and these are some packages, but every package has its own limitations. So you can try researching on your own and identify new solutions which can help to solve this problem on a granular basis. Moving forward, I would like to highlight a very important and one very crucial issue, that is the issue of generalizability. So, the whole idea of artificial intelligence is to build smart systems that can mimic the human brain and perform tasks with precision greater than or at least equal to human beings. So, how far have we reached in the process of mimicking the human brain? I think we are not even close. The main reason behind it is the ability of humans to learn from one situation and apply it to another different situation. This is the idea of generalizability. Capability to gain knowledge from one system and use it to different scenario. Let me explain it with an example. Suppose you have an autonomous vehicle which has been well trained to run on the USA roads. Will that same autonomous vehicle will be able to run on the Indian roads? The answer is no. Because the vehicle has never seen Indian traffic, and it is not a generalized system where it can use its learning of USA traffic and apply it here on the Indian road. So this is the issue. with the generalized systems, and this problem can be solved. So the ability to generalize can help in managing the resources efficiently, and the models will not have to be retrained. Imagine if we had access to such generalized system in today's scenario, then it would have been possible to create a model which was trained on the data of Spanish flu and use that model's learning in the current situation of COVID-19 and help with the process of drug discovery, spread of the virus, and whatnot. So that's the power of generalized system, and we need such type of systems that can solve everything and not just a specific issue. So I was reading on the internet about this problem, and I found out that a truly generalized system can be the one where the robot knows how to make coffee, but it is not making the coffee in that trained environment, but going to a different house, finding the ingredients there and making the coffee. So that is the benchmark, that is the true test of generalizability. If we make such machines which can perform this task, then we can confidently say that we are reaching to the levels of human intelligence, to the levels where AI is not limited to solving a specific problem. So, what are the solutions? The first solution is transfer learning. This is one technique which is currently being used, and it prevents training the model from the scratch. So, the basic idea is that the model has already been pre-trained on a very large data set, and you make very minor tweaks in the model as per your requirement. This saves both time and resources, as the model does not have to learn everything from the scratch. Most of the work has already been done. So, for example, if you want to build a model that can identify by looking at the images whether it's an image of a car or not, then you can probably use a model that has already been pre-trained on images of truck. As trucks are somewhat similar to cars because both have got tires, both have both look alike in some aspect. So this type of system can be used. Transfer learning is currently being used at many places, and this also solves the problem of data set. So the problem that I was mentioning earlier, the problem of requirement of massive data set, it can be easily solved with transfer learning because since you don't require huge data set, you can work with few data images, and the work is almost done. So this will need less data and will give you quite better results. The second solution is capsule. So the capsule concept is still in the early phases of development, and a lot of work is being done by the godfather of deep learning, Geoffrey Hinton. So the idea is to encapsulate the learning obtained from one system and then embed it in a different system so that it can be used to solve a different problem. But as I said, the technique is still in the early phases of development. A lot of work is required to be done. The architecture that we are seeing here is of CapsuleNet or CapsNet, and this architecture says that you can see that the first layer that you see is the input layer. The second layer is the convolution layer. The third layer is nested layer. Now this is what creates the difference between a regular network and a capsule network. In regular network, if you have to add more layers, you will add it one after the other. But in a capsule network, if you have to add more layers, you will add it in a single layer with which are nested. So this is the difference. I will not go much into the technicality here as it is quite complex to understand, and very preliminary knowledge of CNN is required to understand this. So you can read it later on the internet. So this is the basic concept. So finally, to summarize, we have basically six different technical limitations, and all of these limitations invite us to solve them for the better future. We have to identify the solutions and solve these challenges. I hope you enjoyed the session. and that you go back with something. I'm open to questions. Please ask your doubts.
So thank you so much, Bhavna, for such an amazing talk, and it was very insightful to understand more about other these challenges in AI and how you explained about AI that needs to be more explainable because now once we are data scientists, we are dealing with the audience or the customers, and it is a point where we have to explain that why this prediction. So that was a really amazing point that you touched in your talk, and the audience must have got real great insights into the data science field. Now we'll move on to the question answer round.
Yeah,
We
sure.
have a couple of insightful questions from the audience.
Mhm.
Okay, there goes the first question. What are the different ways to improve the quality of data?
So yes, as I said, that quality of data is can be corrected at the level from where it is being collected. So the first step should be that the team which is collecting the data and the team which is using this data should have no communication gap. The clear intentions of collecting the data should be communicated so that the data which is being collected in the first place is correct and that you don't have to spend time in correcting it and cleaning it. So this is the first solution. The second solution can be you have to maintain a variety of quality assurance metrics, and these metrics can be used to can be evaluated at uh, different steps where data is being manipulated. So these are some of the ways in which data quality can be improved.
Yeah, I hope that answers your question. And I would like to add that, as Bhavna just said in her talk, that bad quality data equals to bad predictions. So that is what keeps us driving to improve the quality of the data. So we should keep up with that spirit. Moving ahead to the next question. Does data collection phase involve data when we obtain from offline sources as well as scraping? So,
Y- Yeah.
you answer
So
that?
yeah. So data collection is basically everything which goes into your model. So everything that you are feeding in your model will come into the circle of data collection. So web scraping, offline sources, online sources, Twitter, Facebook, anything that can be helpful in predicting will come into the circle of data collection.
Yeah, I agree with you, Bhavna. Everything that happens before inserting the data into the model or training our model is usually termed as data collection. So I completely agree with you. The next question is by Cheena Jain. How to deal with model errors?
Okay, so basically model errors are specific to model, and first of all we need to look that what type of error are we trying to solve. I'm not clear about the question because it can be the evaluation error or like what error? The error in data collection.
I would like to add, it is most probably that the audience, especially Cheena Jain, is asking in this question is that error caused due to bad prediction is generally error. So
Mhm.
that is what she is asking, that if our model gives a bad prediction, then how do we deal with that? So
So, okay, there are variety of things that can be done. The first thing is feature engineering. You
yes,
need to look into what features can create impact and what features are really helpful in predicting. So you need to do feature engineering, try to identify the features which can have a greater impact on the predictions and use those features in your model training to get better results. The second thing which can be done is you can change the algorithm. If feature engineering is not working, then you should probably look into a different algorithm and change the algorithm. So if you are using boosting, then you should probably shift to neural networks.
yeah. So that is a very explained and thought of answer, and I agree with you that feature engineering usually involves taking those features which have greater impact or dropping those columns which are not relevant to our data or predictions. So, and the next point also is very helpful as you mentioned. So we can move ahead with the next question now. Integrating AI into your existing systems is a process that is more complicated than adding a plug to your browser. How do you know it's working? How do you know it's worth your money?
Yeah, so this is a very good question, and exactly, it's not that simple. AI is not just the ML code that we look into. AI is much more than that. So, from data collection to the final solution, there are many steps in between, and you have to look into everything. You have to manage the infrastructure, you have to look into the maintenance of the software that you have built, you have to build a complete pipeline which sees the data collection, how data collection is happening, how the data is pre-processing, how the model is getting trained. So it is a complex system, and a thorough understanding is required to completely productionize the solution.
Yeah,
Uh,
definitely. So,
and to answer the second part, how do you know it's worth your money? So the first thing, before even productionizing a solution, we need to identify whether this solution is going to work or not. So for that, we do a feasibility study. We check whether the system is even feasible or not. The second thing, we then go to developing a prototype. So in prototype, we make a, a probable solution to the problem, and if the prototype is agreed upon by the client, then we move to the productionizing the solution. So a lot of money can be saved there. So it's not like we get a problem and we kickstart on it. A lot of steps are done, such as feasibility study, prototyping. So this helps to check whether the problem is even solvable or not.
yeah, so definitely. So, China Jen, you can look into prototyping and feasibility study, and that could be the right answer. The next question is, in between the buzz of AI and data science, this session effectively covers challenges that are prevalent in AI. Would you want to comment on this?
Yeah, so basically, data science is AI is a bigger circle, and data science is a subset of it. So these challenges, which I mentioned, are not just limited to the circle of data science. They are also they can be also extended to the circle of AI. So this is just one system, and data science is a subset of AI.
Yeah, so that answers the question. And moving ahead with the next question, being a beginner in AI, I felt AI is the way to go, but now I am unable to understand challenges with algorithms.
Um, so to answer this, basically, if you are starting on and if you have just started and you are fresher in this field, you can be intimidated by the things that are happening in the AI space, and you might feel stuck that you are not moving forward. So a deeper understanding is required. First, you clear all your fundamentals. It is absolutely necessary to get your fundamentals cleared and then move forward. If something is happening, then we have got many resources available online. Like you have got many documents, many videos, and even if that is not helpful, then you have got an online data science community which is so helpful. Like if you have got any problem, you can just go back to them and ask them. So I don't think you should need to feel stuck. Just clear your doubts and move ahead.
Yeah, so I would like to add that it is all about learning from the scratch and like being strong with your basics and then going ahead with one AI technology, maybe like natural language processing and developing your niche, doing more and more in that field. So that's the way to go forward.
Yeah,
Next
absolutely.
question. Yeah, next question is by Vivek Raja. How should I determine which business requirement can be met by giving an AI solution? Any thumb rule to prevent unnecessary use of AI for simple tasks?
Yeah, so that is one important thing that has been highlighted by Vivek. Thank you, Vivek, for bringing this up. So, what happens is, as I said, that AI is deemed as a golden egg laying goose by governments and businesses. So, what businesses try to do, they plug into everything they say that this can be solved by AI. This is not the thing. This is not the reality. everything cannot be solved by AI, and some things can be solved simply by doing applying some simple logic. So we need to first look into the matter if it is solvable by anything simpler than AI. And if it is not possible, then we should step forward and look if AI is actually necessary for this problem or not.
Yeah,
And
definitely.
about the business requirement problems, there should be a clear communication between the client and the AI professionals. They should sit together and try to identify what the client is trying to achieve, and then look into the capability of team, whether the team is capable of solving this problem through AI or not. And even if it's capable, is the problem feasible? So all these things have to be taken into account, and then we can move forward to actually productionizing the AI.
Yeah, I would like to summarize that Vivek, Bhavna is suggesting that you start by understanding your problem, and once you have deeply understood your problem statement, that this is what I need to solve, then you can go ahead by judging whether this problem is a AI problem and requires some complex algorithms or not. Otherwise, you can collaborate with your team and understand the problem from customer's perspective and go ahead with using AI or not in either ways.
Definitely.
So the next question is, there was a boom in AI due to the increase in computation and data. Do you think importance and relevance of AI or ML would die down in the future as it happens with almost every technology?
I don't think so that in near future we are coming towards an end point where the technology cannot grow further. As I already mentioned, so many challenges and we have so many limitations to look into and solve. So I don't think that we will face an end point in the near future at least. So we need to solve these limitations so that the technology can grow more rapidly and can give us some better solutions.
Yeah, I would also like to add, as Bhavna suggested in her talk, that human intelligence and artificial intelligence are not yet the level we want to achieve them. So, artificial intelligence does not do it as good as a human does it right now. So, definitely, there is a gap that we need to cover, a lot of developments that are required in the AI perspective. So the technology is definitely not dying because it has a long way to go and heights to reach as compared to human intelligence. So yes, it is here to stay. And I think that answers all of our questions from this session. And thank you so much, Bhavna, for such an insightful talk and a deep inspiration into data science. And I would like to thank our audience for giving us so many intriguing questions. And in the end, on the behalf of WIDS team, I would like to thank our marvelous speaker, Bhavna Singh, for an amazing session. I would like to encourage the audience to stay tuned for the next session at 4 p.m. today. We are signing off.
Thank you. Bye bye.
Thank you. Bye.
Good work, Shabika. This was like far, far, far better than yesterday. मतलब it was very good. मतलब बहुत अच्छा था. मैं आपको कनेक्ट करती हूँ WhatsApp पे.